Okay, well, good morning, everybody. Wow, I didn't expect this, to be honest. So I'm glad that you are all here, and I'm happy to be here in this nice location. Good weather, what else can we ask for? So I'm Jochen Eissler, as Eileen already said. I'm working for the Waldner Group since more than 20 years. And today I will tell you a little bit about automation systems. So for some of you it might be very boring, and for the ones who are the experts, I'm not the expert at all. But let's see. So we in Waldner have one vision. We would like to enable you, our customers, to secure the future of the people through nutrition, health, and education. This is what we aim for with all of our products, and this is what we stand for. But today I'm here on behalf of company HAS. HAS is our long-term automation partner, and we bought this company in 2022. So we work together with HAS since more than 16 years, and last year we had the opportunity to buy them, and now they are part of the Waldner Group. So HAS is fully focusing on automation systems. We have 58 people, mainly electrical engineers, software engineers, technicians, and project managers. HAS offers automation systems for preparation, storage, and distribution of pharmaceutical sterile products, as well as of clean media. We are located down here in the south of Germany, next to Wangen, where company Waldner is located. And the airports of Stuttgart, Munich, and Zurich are all around 1.5 hours away. So we are very good reachable. We live and work in a very nice area, so it's worth to come by. So whenever you have time, you are invited to visit us. Okay, why do we have automation systems at all in our facilities, in your production plants? Well, basically, we need to fulfill several obligations given to us by the FDA, by other legislations. So we have to fulfill the FDA CFR Part 11. We have to be compliant to the GMP Annex 11. We have to have audit trails. We have to have electronic record and signature according to 21 CFR Part 11. We need to have a consistent data check. We need to have data safety and data integrity. Then, of course, in large companies, we also want to connect our production control system to an MES system, for example, SAP or something else you have. And we have a central user administration with access control. We, of course, nowadays, it's even more important, need to fulfill cybersecurity demands. And what is also very important, we need to have a system-supported versioning of our recipes so that when you generate a new recipe, it automatically generates a new recipe number. And we have to follow the ISA 88 standard, which is a standard for process control of batch units. And the soft and hardware solution for this, at least to our opinion, and which fulfills these requirements fully, it's Siemens PCS7 and Siemens Batch. You know, at the end of the presentation, you might think, okay, this guy is working for Siemens. No, it's not the case, but I'm convinced that this is the right tool. And before we go into the presentation, one very important thing, this should not be a monologue. Whenever you have a question, please do not stop to interrupt me. Do not hesitate to interrupt me. And then it gets a bit more interesting, maybe. So as I said, these two tools from Siemens are the ones we are using to automate batch process in the pharmaceutical industry. And we will now take a closer look first on the system itself, and then I have also some slides from a project we did. So PCS7 is the control unit. It's a process control system. It's a top segment process control, and it can work for medium and large enterprises. And the reason to implement a PCS7 system is that it comes already with the full requirements for CFR 21 Part 11, that we have a homogeneous look and feel, meaning if someone has already worked with the PCS7 system, it will always look the same, no matter in which company he works, no matter which line you're using. If you use the system, the look and feel is always the same. So it makes it very easy to train people, to adapt to new products, to new product lines. Then also it has a standard interface to your MES system. It has a very flexible structure, so it's suitable for all industry, medium size, small size, or even big size. And it's investment secure due to step-by-step enlargement. So you can start with a small solution and then go to bigger solutions. And of course, as the regulations are changing, also Siemens is adapting to new regulations automatically for a lot of things which we need also for your documentation. We get white papers from Siemens, so you can show your auditor everything is fine, which is also an important fact nowadays. We have a high level of data and cybersecurity demands, which are filled, and of course, Siemens has approved disaster recovery procedure. So this is the hardware part. Now, the software part is the Simatic batch system, which is a software packaging for planning, controlling, and reporting of batch processes. Again, we fulfill the requirements of CFR 21 Part 11. We have a high product quality and a deterministic process of production. We support with this software the operators very much, because depending on what you would like to achieve, you can walk the operator through a recipe step by step with messages on the screen. You can tell him what he has to do now or what he has to do next. It's very flexible in operation. So if you are a CMO or a CDMO, you easily can adapt to new products you get from your clients, from your customers, but I will show you this later on. We have a separation of the automation task and the recipe creation task. So while the production is running in parallel, you can create new recipes for the next batch, for example. Then, very important, we have an automatic batch report at the end of each batch. We can ensure the maintainability, the reuse of library objects, and therefore we have a lower life cycle cost. As mentioned before, the homogeneous look and feel also is valid for the software. And also very important nowadays, we have a very simple validation system because we use library objects, archiving and reporting of components. So this is already standard and nothing has to be programmed or implemented. Okay, now we come to the fun part. So this would be a typical network topology for an automation system with PCS Siemens S7. On top, these are the HMIs. So this is where your people, your operator, are actually working with the system. But they are just screens. They have no intelligence, nothing. The intelligence is here. So these are SYN clients, and these are virtual machine clients. So all the intelligence is sitting here, and the HMIs are connected with the virtual clients via a bus system. This is a green line. Then also the operation server, as well as the batch server, they are here. They are virtualized. They are not really existing. So you need to have a big, huge piece of hardware, and then these servers are placed as a software on the hardware, which gives you the big benefit that you only need to invest once in the infrastructure, and the rest is software update. So it's also very cost sensitive. You do not need to have a lot of servers available because you only need one big server where everything can run through. So all this part, which is in this light color, this is virtualized. The only real part then down here, number 9, this is the actual automation system. This is the PCS7 hardware. And from the virtualized system to the hardware, we have the blue line, which is also the plant bus. Then on number 7, here we can create the recipes in parallel. And number 8, it's our historian server, where we can get all the data later on. And also very important, number 6, this is the engineering station. Once you have to change something in the process, you can do this via the engineering station. Okay, this was theory. Now we come back to the reality. I will show you some examples from a real line we did. So this line was for the pharmaceutical industry. It was for basically 3 different systems producing sterile solutions. So we have 3 production facilities, sterile production 1, 2, 3. We use isolators for the sterile handling of the API, but we also work with highly active substances. So the isolator had to be sterile and had to protect the operator. But my colleague Dirk Collins will later on go closer into the details of the process itself. We use the PCS7 and PCS7 batch to control the production at the batch process, and we had a process historian server for the long-term data storage. And this is just some impressions from the line. We divided the clean room side, which is here, from the technical side. So everything on the left side, it's in the clean room. So you see we have almost no valves, nothing. And all the technical features are behind the wall in the technical area. So this also gives you the benefit to work in the clean production environment. And this is just another example, but as I mentioned, Dirk will give you more details on this later on. But I have a question for you. You see maybe here some pneumatic hoses and things like this. What do you guess? How many meters of pneumatic hoses we had to use in this line? It's 5,000, around 10,000, more than 15,000. So who thinks 5,000 meters? Nobody? 1, 2, 3, okay. Around 10,000 meters? More than 15,000 meters? So the majority is right. We used more than 20,000 meters of pneumatic hoses in those 3 lines. And here you will see why. We have around 1,000 process valves which have to be controlled. We have more than 400 I/O signals. We had 3 PCS7 automation units. We had integrated mobile vessels from which we also could keep the status, but I will come to this later on. Altogether, we had 18 stainless steel HMIs to control the process in the different locations of the plant. We have a redundant system architecture. So this means we have redundant OS servers and redundant batch servers, in total 6 of each. As mentioned before, we have a recipe station to design and handle the recipes. We have an engineering station for developing and changing of hardware and software projects. We have a historian server, and also, as mentioned before, all server and HMI hardware is virtualized on a virtual machine. And this is the setup for this unit. So again, you can see, just 1 second. On top, we have the 18 HMIs. Here we have the engineering station. We had 2 engineering stations. We had the protocol printers for each line, so SP1, 2, 3, SP1, 2, 3. Here we have the virtual machine with 6 OS servers and 6, batch servers, that's what I was looking for. And they are redundant. So even if one of those machines is not working, as they are mirrored on both sides, the lines will still run. Then here we have the historian server, and underneath the 3 PCS7 systems. And this is the overview of one of the lines. In this case, it's the SP2. So everything in this orange color, it's in the technical area. So all the hardware, the electrical cabinets, the CIP system is also in the hardware. And then in the clean room area, we have the isolators, we have the mobile vessels, we have the HMIs to control everything, we have the CIP panel, and all the vessels which you see here, they are connected to the system, and the system knows at every minute in which status the vessel is. So it can be clean, it can be used for production, it might be, well, not able to work because something is wrong, then the system will also know this, and the operator, and this is a good thing, will not be able to use the vessel. So there can be no mistake, no misleading function, nothing. And now we come into the details. So here, this is the, well, just 1 second. This is the standard look and feel of a visualization. So on top, we have here number 1, the last active alarm would be displayed. Number 2, you will see the active user who is working with the line and the system time. Number 3 is your menu, so you can navigate through the statuses of the system itself. Here you will see one sub-process which is shown, and this window gives you the status of one valve, and you can have also manual interaction if you have the right password level. Then you can determine to open a valve, which is a normally closed valve, or you can change the speed of the motor from the agitator, things like this. And the good thing with PCS7, once we write a valve, an actuator, whatever, in the hardware list, then it automatically creates the icon. So we only have to do the connections. So the lines have to be done manually, but they are based on the PNID, which we did, of course, before, and which we, of course, got your approval for, and then we start to programming. And the number 5, it's the navigation, the standard navigation within the PCS7 system. So here we see the same picture, but this is just an example for an isolator. So we can see the picture of the isolator and all the valves, hoses, etc. connected to it. Here we have the same for a transfer panel. So actually everything you see here, it's based on the PNID. You will see the status of each valve, if it's closed, if it's open. You will see the connections. If it's flexible hoses, then of course they all have indicators so that we see it's connected or not connected. And the same for the CIP unit, which is in the technical area. And of course for the CIP panel, which is in front in the clean room area. And last but not least, this is the transfer and filling panel. Once the process is over, and Dirk will show you this later, we move the mobile vessel to the transfer and filling panel and connect it there, and then the product is filled and transferred to the filling machine. Also, one very important point, alarms. We often have alarms. Nobody is free of alarms, but then it's good if we can handle them very easy. So with number 1, you can acknowledge one alarm, a single alarm. Number 2, you can acknowledge a group of alarms. 3, you can select a dialog window and add some information there. Then the number 8, this is the overall look of the alarm field. With 5, you can display messages, and with 7, you can display all existing messages. So again, we have the advantage that the look and feel is the same like in the slides before, so it's easy for the operator to work with the system. Even more important, audit trail, because this is what you need, what your auditors will ask you for. And here, one important point, we will always see if one operator did a change and what he changed. So it's 100% reliable, and you can see what happened even later on. Then, of course, we can create almost all kinds of trends. Everything you can do by yourself. You can choose which valve, which pressure, whatever you would like to take, and can create a trend. You can store this trend and use it later on again. But the main advantage of the PCS7 system is the recipe creation. So I don't know if someone of you has ever worked with a configurable recipe. Someone has done this before? No? Because in many times, if you have an automation, the recipe and everything is hard programmed. If you want to change something in the recipe, you need your automation company to come and do the change for you. You only have a chance to work with parameters which you can set to certain areas, but you never are able to change the recipe by yourself. And this is a totally different story with PCS7, because here we have recipe operation procedures. These are the green rectangles. And basically it could be that one recipe operation procedure would be agitation. Another one would be heating. The next one would be, I don't know, adding something. All these recipe operations you can choose and put in the direction you would like to have it. So there are almost no limitations to do this. So what we see here, it's a typical, this is a batch control center where you do your recipe. Yeah? So number 1 is the master recipe, could be this one. And then you have in 2 the orders you have to work on. In 3 you have the materials which you need for your process. And 4, this is the active recipe. In 5 you will find some status information about the recipe. And in 6 you will find the already existing versions of this master recipe. So again, if we go now to a live recipe in runtime, so all these on the top are the sub-recipes or the sub-units. Then number 2 will show a successfully completed recipe part. Number 3 is in operation at the moment, and we can have parallel operations of 2 steps, like you see here. And 4 is a currently active recipe part. 6 is on hold because something went wrong. And 7 is a non-active recipe. This is already done or something like this. So it's very easy and understandable for the operator to work with the system, and also for your people who have to create the recipes. And last but not least, when we have done our job, we would like to have a protocol. Also, the protocol can be created by yourself. You have different options, different parts you can use. So in the top header, we normally have the master recipe name, the batch ID, and the time the recipe was running. Then in the main recipe sequence, we have the hierarchical structure of the recipe with the subsidiary elements, and we have the logical structure of the recipe, can also see in the process overview. And last but not least, for each recipe item, you can get the start-end time. You can have specified set points which are shown, or actual values of the recipe parameters, and the interactions which have been done by your operator will also be displayed. Okay, do we have any questions? And the good thing, this cannot only be done for new lines, but we also can retrofit older systems with a new PCS7 system. So if this is interesting for you, of course, don't hesitate to ask me. I'm around the whole day. And yeah, I hope you have a nice day. Enjoy the lectures which will follow. Enjoy the good food and tea and things like this. And thank you very much.
There will be a questions and answers session, but this is a bit complicated. Maybe you want to ask now before we forget everything.
As I said, for those who are not so experienced, it's maybe too boring, and those who are experts, they already know everything.
Okay, if there's any question, I can bring the microphone.
Otherwise, we do it later, also face-to-face. I'm here.
Okay, so now it's coffee time.
Thank you very much.
Thank you.